Another day. Oh, yes, another day. Chapter 21. Element. The words atom and element express basic notions in the analysis of matter. To some extent, their meaning seems to be the same. Atoms or elements are usually understood to be ultimate units, the parts out of which other things are formed by combination. But as soon as further questions are asked about the divisibility or indivisibility of these units, or about their number and variety, we are confronted with differing conceptions of the atom and with a theory of the elements which is opposed to the atomic analysis of matter. Even when the two notions are not opposed to one another, they are not interchangeable. Atom has a much narrower meaning. It usually designates a small particle of matter, whereas element signifies the least part into which anything at all can be divided. It is this broader meaning of element which permits Euclid to call his collection of the theorems, in terms of which all geometric problems can be solved, the elements of geometry. According to Aristotle, this is true not only of geometrical proofs, but also, in general, of the elements of demonstration. For the primary demonstrations, each of which is implied in many demonstrations, he says, are called elements of demonstration. From this it follows that elements will be found in any subject matter or science in which analysis occurs, and not only in physics. An element, writes Nicomachus in his Introduction to Arithmetic, is the smallest thing which enters into the composition of an object, and the least thing into which it can be analyzed. Letters, for example, are called the elements of literate speech, for out of them all articulate speech is composed, and into them finally it is resolved. Sounds are the elements of all melody, for they are the beginning of its composition, and into them it is resolved. The so-called four elements of the universe in general are simple bodies: fire, water, air, and earth. For out of them, in the first instance, we account for the constitution of the universe, and into them, finally, we conceive of it as being resolved. This explains why books in so many different fields have the word element in their titles, There are the elements of grammar or logic, the elements of language or music, elements of psychology or economics, elements in one subject matter or science are analogous to elements in another because in each sphere they stand to everything else as the simple to the complex, the pure to the mixed, the parts to the whole. Thus, the factors of price may be said to function in economic analysis as do the parts of speech in grammatical analysis. Another illustration comes from the theory of the four bodily humors in ancient physiology. In the traditional enumeration, which goes back to Hippocrates, they are blood, phlegm, yellow bile, and black bile, and they function analytically as do fire, water, air, and earth in ancient physics. They make up the nature of the body of man, according to a Hippocratic treatise on the nature of man, and through them he feels pain or enjoys health. Perfect health is enjoyed by man when these elements are duly proportioned to one another in respect of compounding power and bulk, and when they are perfectly mingled. Galen, in an analysis of temperaments, explains all varieties of temperament and complexions of physique in terms of these humors, either by their mixture or by the predominance of one or another. Thus the sanguine, phlegmatic, choleric, and melancholy temperament is accounted for by the excess of one and a deficiency of the other humors. Still another physiological application of the notion of element is to be found in the ancient division of tissue into flesh and bone, or in the more elaborate modern analysis of the types of cells which composite all living matter. These illustrations indicate that the irreducibility of elements to anything simpler than themselves does not necessarily mean that they are absolutely indivisible. Cells can be further divided into nucleus, protoplasm, and a membrane without ceasing to be the elements of tissue. Parts of speech, nouns, verbs, adjectives, can be further divided into syllables and letters without ceasing to be the elements of significant utterance. Letters, treated as the elements of language, can be physically divided. The fact that terms are sometimes regarded as the logical elements out of which propositions and syllogisms are formed does not prevent a distinction from being made between simple and complex terms. Nicomachus calls the triangle elementary among all plane figures, for everything else is resolved into it. But it into nothing else. Yet the triangle is divisible into the lines which compose it, and these lines, in turn, are divisible into points. When Nicomachus says that the triangle is the element of all other figures and has itself no element, he does not mean that the triangle is absolutely indivisible, but only relatively so. Relative to the analysis of plane figures, there is no simpler figure out of which the triangle can be formed. Similarly, relative to the analysis of significant speech, there is no simpler part than the word. Relative to the analysis of melody, there is no simpler part than the tone. Musical tones may be physically, but they are not musically complex. The definition of element can also be approached by comparing its meaning with that of principle and cause. All three terms are brought together by Aristotle in the beginning of his Physics, when he declares that we attain scientific knowledge through acquiescence with the principles, causes, and elements of things. The word principle occurs almost as frequently as element in the titles of books which claim to be basic expositions or analyses. The two words are often used as synonyms. Lavoisier, for example, says that we can use the term elements or principles of bodies to express our idea of the last point which analysis is capable of reaching. To discover any difference in the meaning of element and principle, it is necessary to specify their correlatives precisely. Out of elements, compounds or mixtures are formed. From principles, consequences are derived. In logic, for example, we say that terms are the elements of propositions. The proposition, Socrates is a man, comprising the terms Socrates and man, but we say that axioms are the principles from which conclusions are derived. This does not prevent the same thing from being viewed in different connections as both element and principle. As an element, because it is the simple part out of which a more complex whole is composed, and as a principle, because it is the source from which something else is derived. The parts of speech in grammar are the elementary components of phrases and sentences. They are also the principles from which the rules of syntax are derived. The third notion, which belongs with element and principle, is cause. Its correlative is effect. Again, it can be said that that which is an element is in one connection, and a principle in another can be regarded as a cause from still a third point of view. In Aristotle's physical treatises, for example, matter is regarded in all three ways. It is an element of all bodies, for they are substances composed of matter and form. It is a principle of change, since from matter, form and privation, change is derived. It is a cause, i.e., the material cause of certain results. But it must also be observed that everything which is any one of these three is not necessarily both of the others also, since an element, according to Aristotle, is a component immanent in a thing. Anything that is an extrinsic principle or cause cannot be an element. Thus, the action of one body upon another is a cause and a principle, but not an element. Referring to these distinctions, Aquinas declares that principle is a wider term than cause, just as cause is more common than element. The chapters on cause and principle tend to substantiate this observation about the scope of these ideas in the tradition of Western thought. The basic issues concerning elements occur in the analysis of matter. Before Plato and Aristotle, the early Greek physicists had asked such questions as, from what do all things come? Of what are all things made? A number of answers were given, ranging from one kind of ultimate, such as earth or fire, through a small set of ultimate kinds, to an infinite variety. The classical theory of the four elements is the middle answer, avoiding the extremes of unity and infinity. According to Galen, it was Hippocrates who first took in hand to demonstrate that there are in all four mutually interacting qualities, and who provided, at least at the beginnings of the proofs to which Aristotle later set his hand, in developing the theory of the four elements. Galen also indicates that it was a subject of controversy among the ancients whether the substances as well as the qualities of the four elements undergo this intimate mingling, from which results the genesis and destruction of all things that come into and pass out of being. Aristotle, in his treatise on generation and corruption, enumerates the various senses in which the physicist considers elements. We have to recognize three originative sources or elements, he writes. Firstly, that which is potentially perceptible body. Secondly, the contrarieties, e.g. heat and cold. And thirdly, fire, water, and the like. The potentially perceptible body is identified with prime matter, and since this has no separate existence, but is always bound up with a contrariety, it can be ruled out from the usual notion of element. The elementary qualities, the contrarieties, named secondly, are the hot and cold and dry and moist. The so-called elements, fire, air, water, and earth, are left to the last and are mentioned only thirdly. Aristotle says because they change into one another, whereas the contrarieties do not change. The elementary qualities attach themselves by couples to the apparently simple bodies. In consequence, Aristotle writes, fire is hot and dry, whereas air is hot and moist, and water is cold and moist, and earth is cold and dry. Each of them, however, is characterized par excellence by a single quality. In terms of these simple bodies and the elementary qualities, all other material things can be explained. In contrast to the elements stand the mixed or compound bodies, in the constitution of which two or more elements combine. There may be many kinds of mixed bodies, but none is irreducible in kind, as are the four elements. Any mixed body can be divided into the different kinds of elementary bodies which compose it, whereas the elementary bodies cannot be divided into parts which are different in kind from themselves. A living body, for example, may contain parts of earth and water, but the parts of earth are earth, and the parts of water, water. It is precisely the mode of divisibility that Aristotle declares is the fundamental question. In answering this question, he opposes the theory of the four elements to another Greek account of the constitution of matter, the atomic theory developed by Leucippus and Democritus, and expounded for us in Lucretius's poem on the nature of things. According to the Greek atomists, matter is not infinitely divisible. If nature had set no limit to the breaking of things, Lucretius writes, by this time the bodies of matter could have been so far reduced that nothing could, within a fixed time, be conceived out of them and reach its utmost growth of being. There must then be a fixed limit to their breaking a limit in physical division, which ultimately reaches units of matter that are absolutely indivisible. Lucretius calls them first beginnings of solid singleness, not compounded out of a union of parts, but rather strong and everlasting singleness, the seeds of things, or atoms. The Greek word from which atom comes literally means uncuttable. From this, it is evident that Aristotle can deny the existence of atoms, while at the same time he affirms the existence of elementary bodies. The elements, unlike the atoms, are not conceived as indivisible in quantity, but only as incapable of division into diverse kinds of matter. In the Greek conception of atom and element, the difference between them lies in this distinction between quantitative and qualitative indivisibility. The atom is the least quantity of matter. It cannot be broken into quantitative parts. The elementary body is not atomic. It is always capable of division into smaller units. But all of these units must be of the same kind as the elementary body, undergoing division. The element is indivisible only in the sense that it cannot be decomposed into other kinds of matter, as a mixed body can be decomposed into its diverse elements. The atom cannot be divided in any way. Only compound bodies can be divided into their constituent atoms, all of which are alike in kind, differing only quantitatively in size, shape, or weight. Different kinds of matter occur only on the level of compounds and as the result of diverse combinations of atoms. This last point indicates another contrast between atoms and elements in ancient physical theory. The elements are defined, as we have seen, by their qualitative differences from one another, or more strictly, according to combinations of elementary sensible qualities, hot and cold, moist and dry. By virtue of the qualities peculiar to them, the four elements stand in a certain order to one another. Water and air, according to Plato, are in the mean between fire and earth, and have the same proportion so far as possible. As fire is to air, so is air to water, and as air is to water, so is water to earth. The quality which two of the elements have in common provides the mean. Thus, fire and air are joined by the common quality of hot, air and water by moist, and water and earth by cold. When their analysis reached its greatest refinement, the ancients recognized that the earth, air, fire, and water of common experience do not actually have the purity requisite for elements. They are not simple, but blended, Aristotle writes. And while the elements are indeed similar in nature to them, they are not identical with them. The element corresponding to fire is such as fire, not fire. That which corresponds to air is such as air, and so on with the rest of them. Thus, the four elements are only analogous to, for they are purer than ordinary earth, air, fire, and water. Yet their names continued to be used as symbols for the true elements, a connotation which is still retained when we speak of men struggling against or battling with the elements. It will no doubt be a matter of surprise. Lavoisier writes in the preface to his Elements of Chemistry that in a treatise upon the elements of chemistry there should be no chapter on the constituent and elementary parts of matter. But I shall take occasion in this place to remark that the fondness for reducing all the bodies in nature to 3 or 4 elements proceeds from a prejudice which has descended to us from the Greek philosophers. The notion of 4 elements, which, by the variety of their proportions, compose all the known substances in nature, is a mere hypothesis, assumed long before the first principles of experimental philosophy or of chemistry had any existence. This does not mean that Lavoisier entirely rejects the notion of elements in chemical analysis. On the contrary, he says that we must admit as elements all the substances into which we are capable by any means to reduce bodies by decomposition. His quarrel with the ancients chiefly concerns 2 points. The first is on the number of elements, which he thinks experiment has shown to be much greater than the 4 of classical theory. The second is on the simplicity of the experimentally discovered elements. They can be called atoms or simple bodies only if we do not thereby imply that we know them to be absolutely indivisible, either qualitatively or quantitatively. We are not entitled to affirm that the substances we consider as simple may not be compounded of 2 or even of a greater number of principles, merely because we have not yet discovered the means of separating them. In modern physics and chemistry, the distinction between element and atom seems to be abolished. The same unit of matter is at once both an atom and an element. The table of atomic weights is also a chart of the elements. The classification of atoms is both quantitative and qualitative. Qualitative in the sense that the atoms of different elementary kinds of matter differ in their active properties. According to the ancient meaning of the terms, the molecule would seem to be both a mixture and a compound. Mixed in that it can be broken up into other kinds of matter. Compound in that it can be divided into smaller units of matter. But in modern theory, the meanings of compound and mixture have also changed, the molecule being classified as a compound rather than a mixture. The combination of the elements to form molecular compounds is determined by the proportion of their weights or values, rather than by a fusion of their qualities. The most radical change in theory is not this, however, nor is it the increase in the number of the elements from 4 to more than 94, but the ordering of the elements by reference to their atomic weights rather than by the contrariety of their qualities. It results from the discovery that an atom is not uncuttable, and that new elements can be produced by atomic fission. Faraday's experimental work in ionization and in electrochemical decomposition lies at the beginning of the physical researches which have penetrated the interior structure of the atom and isolated smaller units of matter. Even before atoms were experimentally exploded, analysis has pictured them as constituted by positive and negative charges. As the result of his researches, Faraday, for example, conceives of atoms as mere centers of forces or powers, not particles of matter, in which the powers themselves reside. The atom thus ceases to be a little unchangeable, impenetrable piece of matter, and consists of the powers it exercises. What was ordinarily referred to under the term shape becomes the disposition and relative intensity of the forces that are observed. With Faraday, it is evident that the meaning of atom has departed far from the sense in which Lucretius speaks of units of solid singleness, or Newton of solid, massy, hard, impenetrable, movable particles, incomparably harder than any porous bodies compounded of them, even so very hard as never to wear or break in pieces, no ordinary power being able to divide what God himself made one in the first creation. With the conception of the elements as different kinds of atoms, then with the discovery of radioactive elements undergoing slow disintegration, finally with the production of isotopes and new elements through atomic change, the meaning of element has moved equally far from its original sense. Do these altered meanings change the basic issues in the philosophy of nature? Are these issues resolved or rendered meaningless by experimental science? The central point in the theory of elements is an irreducible qualitative diversity in kinds of matter. The elements of modern chemistry may no longer be elementary types of matter in the strict sense of the word, but the kind of difference which would be strictly elemental may be found in the distinction of the positive, the negative, and the neutral with respect to the electrical charge of subatomic particles. Similarly, the central point in atomism as a philosophy of nature is the existence of absolutely indivisible units of quanta, units or quanta of matter. In other words, the denial that matter is infinitely divisible, that any particle, no matter how small, is capable of being broken into smaller parts. The strict conception of the atom is, therefore, not invalidated by the experimental discovery that the particles called atoms are not atomic, that they are themselves complex structures of moving particles, and that they can be physically divided. It makes no difference to the philosophical atomist whether the particles which constitute molecules, or the particles, the electrons and protons, the neutrons and mesons, which constitute atoms, are atomic. Even if further experimental work should succeed in dividing these subatomic particles, the question could still be asked, is matter infinitely divisible regardless of our actual power to continue making divisions ad infinitum? Since the question, when thus formulated, cannot be put to experimental tests, the issue concerning atoms would remain. That issue would not refer to any particle of matter defined at a certain stage of physical analysis or experimental discovery. It would consist in the opposition of two views of the nature of matter and the constitution of the material universe. The affirmation, on the one hand, that truly atomic particles must exist, and the denial, on the other, that no particle of matter can be atomic. The affirmative arguments of Lucretius, Newton make the constancy of nature and the indestructibility of matter depend on the absolute solidity and impenetrability of matter's ultimate parts. The negative arguments of Aristotle and Descartes proceed from the divisibility of whatever is continuous to the conclusion that any unit of matter must have parts. The philosophical doctrine of atomism, in the form in which Lucretius adopts it from Epictetus, insists upon void as the other basic principles of the universe. Nature, he writes, is founded on two things. There are bodies, and there is void, in which these bodies are placed, and through which they move about. Compound bodies are divisible because the atoms of which they are compounded are not absolutely continuous with one another, but are separated by void or empty space. That is why they are not solid or impenetrable, as are the atomic particles which are composed of matter entirely without void. In Newton's language, hardness must be reckoned the property of all uncompounded matter. For if compound bodies are so very hard as we find some of them to be, and yet are very porous, how much harder must be simple particles which are void of pores. The opponents of atomism tend to deny the existence not only of atoms, but of the void as well. Descartes, for example, denies that there can be any atoms or parts of matter which are indivisible of their own nature. For however small the parts are supposed to be, yet because they are necessarily extended, we are always able, in thought, to divide any one of them into two or more parts. For the same reason, he maintains, there cannot be a space in which there is no substance, because the extension of space or internal place is not different from that of body. The physical world on this view is conceived as what the ancients called a plenum, continuously filled with matter. This controversy over void and plenum is elaborated in the chapter on space. Although he uses the language of atomists, Faraday seems to agree with Descartes rather than with Newton. He pictures matter as continuous throughout, with no distinction between its atoms and any intervening space. Atoms, he thinks, instead of being absolutely hard, are highly elastic, and they are all mutually penetrable. He compares the combination and separation of two atoms with the conjunction of two sea waves of different velocities into one, their perfect union for a time, and final separation into the constituent waves. Such a view of the constitution of matter, Faraday writes, leads to the conclusion that matter fills all space, or at least all space to which gravitation extends. The very continuity, the voidlessness or lack of pores, which the opponents of atomism insist is the source of matter's infinite divisibility, the atoms seem to give as the reason why the ultimate particles are without parts, hence simple, solid, and indivisible. On still other points, there is disagreement among the atomists themselves. Not all of them go to the extreme of denying existence or reality to anything immaterial, nor do all insist that whatever exists is either an atom or made up of atoms and void. In the tradition of the great books, the extreme doctrine is found in Lucretius alone, though it is shared by Hobbes and is reflected in the Leviathan. It is not expounded there. It is developed by his treatise concerning body. For Lucretius, the atoms are eternal as well as indestructible. The first beginnings of all other things are themselves without beginning. In time gone by, Lucretius writes, they moved in the same way in which now they move, and will ever hereafter be borne along in like manner, through an endless succession of worlds, each of which comes to be through a concourse of atoms, each in turn perishing as with decay. That concourse is dissolved. Newton writes in what seems to be a contrary vein, it seems probable to me, he says, that God in the beginning formed matter in solid, massy, hard, impenetrable, movable particles. All material things, he continues, seem to have been composed of the hard and solid particles above mentioned, variously associated in the first creation by the counsel of an intelligent agent. Nor does Newton appeal to the properties and motions of the ultimate particles except to explain the characteristics and laws of the physical world. Unlike Lucretius and Hobbes, he does not, and there seems to be some evidence in the optics that he would not reduce the soul of man to a flow of extremely mobile atoms, or attempt to account for all psychological phenomena, thought as well as sensation and memory, in terms of atoms buffeting atom, of atom buffeting atom. The atomic theory of the cause of sensation is not limited to the materialists. Writers like Locke, who conceived man as having a spiritual nature as well as a body, adopt an atomistic view of the material world. The different motions and figures, bulk, and number of such particles, he writes, affecting the several organs of our senses, produce in us those different sensations which we have from the colors and smells of bodies. Furthermore, the distinction, which is here implicit, between primary and secondary sense qualities is not peculiar to atomism. It can also be found in a critic of atomism like Descartes. The atomistic account of sensation is nevertheless a critical significance in the controversy concerning this type of materialism. Critics of atomism have contended that the truth of atomism as a materialistic philosophy can be no greater than the measure of its success in explaining sensation, the source upon which the atomist himself relies for his knowledge of nature. In terms of the properties and motions of particles themselves, imperceptible. Yeah, there's been some updated science since 1952. On how atoms seem to behave, or photons. Light photons. There's this concept of potential versus actual materialization. Something like that. This mouse is messed up. And then the idea that human consciousness seems to affect how matter behaves. Which is not what you'd expect when you first come into being in a world. It makes more sense that the world exists and you're just kind of moving around it. And because everywhere you look, there's already something there. But it could be that it's not there until you look at it. The exact moment. Which is why the question, if a tree falls in a forest, nobody's there to hear it, does it make a sound? People have wondered that. And the answer could be no. Crap. My face looks so weird. Got some kind of Hannibal Lecter skin on my face. progress. I think probably I should probably read things like science and matter before I read all these more specific topics that kind of fall under that category. And basically all the stuff relating to government I'm kind of saving for last. Politics and social things. So that's a big topic of discussion.